Okay, guys, we're going to start section 5.5 today. We're going to split this up into smaller parts, so this will be part 1. In today's lesson, our goal is to solve exponential and logarithmic equations. Now, our goal actually in part 1 is only going to be to solve exponential equations. Exponential equations are when we have exponents that have a variable in it, as you can see here on A, B, and C. Now we have a really basic property here, and it's going to help us to solve exponential equations. And that basic property says that it's called the base exponent property. It says when you have a to the power of x equals a to the power of y, that means that x must be the same number as y. X must be equal to y if they have the same base a. Okay? So what we can do, actually, let me show you a real basic one. So say if we have 2 to the power of x equals 2 to the power of 3. That means that x must be 3. That's all that basic property tells you. So next, if you can write each side of an exponential equation with the same base, then you can drop the base and set the exponents equal to each other to solve. What does that mean? Let me show you a really basic problem what that means. Say if we have 2 to the power of x equals 8, okay? What that means is, remember, we're solving for x, so what is x allowed to be? Well, you can change the 8, the bigger number, to have a base of 2. So let me carry that down. Now, what does 8 become to have a base of 2? Remember that 8 is the same thing as 2 times 2 times 2, which is 2 to the third power. So you can see that now that they have the same base, we can see the property that we just discussed. When they have the same base, the bases can drop out, and you just write x equals 3. So that's what we're going to be doing here today in 5.5 part 1. So example 1. We have 2 to the power of 3x minus 7 equals 32. So as we said in the last paragraph, last example, we want to see and go, okay, can I bring that 32 down to have a base of 2? In other words, 32 is 2 to the power of what? Can I get it into 2 to the power of what? Yes. We all know, we've hit it about 100 times in this class, that 32 is 2 to the 5th power. So bring down the left side. So now that they have the same base, we're allowed to use the property that says just drop the bases and write down the resulting equation. 3x minus 7 equals 5. And then we can just solve this equation to find out what x is. Add 7 to both sides. And then divide by 3, and you'll have x is 4. Okay, so we used the properties there, the base exponent property, and the paragraph to the right. So our goal here today is we're going to see if a bigger number, we can match the base with the smaller numbered base. Okay, I don't want to do B yet. I actually want to do C. C is much easier. So 4 to the power of 2x minus 11 equals 64. I got to think, can I turn 64 into a power with a base of 4? Think about that for a second. Can I turn it into a power with a base of 4? Yes, I can. 4 to the power of 3 is 64. So I change 64 to a power that has the same base 4. And that's important. We do have to turn it into the same base. So now that they both have the base of 4, the property says we can just drop off the bases and then write a new equation. Set the exponents equal to each other. And then we solve for x. We're going to add 11 to get to x is 14. And then we're going to divide by 2 to have x is 7. And that's it. So let's take a look at letter B now. All right, it looks like we definitely upped the difficulty here. But just think, we got an 8 and a 2 and an 8. So we got to think, can I bring the 8s down to have 2s? Yes, we know that from earlier when I said up here. With the 8, I turned it into 2 to the third power. We can bring it down to a 2. So 8 turns into 2 to the third power. Bring down the 2 to the power of 8x times. And then we got to be a little careful here. The 8x squared, the x squared is an exponent. So we got to be careful that we're keeping it as an exponent. And then we have 2 to the power of 3x squared. Okay. 8 turned into 2 cubed, and then just put that cubed with the x squared. All right, so now that they all have 2's, we do want to use some rules here. How can we set up this equation? Well, actually, the 2's on the right, we want to put those together. Now, if you remember exponent rules, when we have 2 with an exponent times 2 with another exponent, what are we allowed to do? We're allowed to write 2, and then we are allowed to add the exponents together. Okay? This is, not going to lie, this is a very challenging problem coming up. Because you guys might go, okay, where do I go from now? Well, I have condensed it to a single 2, so I can drop the 2's now and write the next equation in. Now, it gets difficult because people forget, they know how to solve those easy linear equations like we had in A and C, but they forget what to do when we have when we have a quadratic equation where we have an exponent of 2. Now, remember, an exponential sorry, I keep saying exponential. A quadratic equation, we always want it set equal to 0. Now we're gonna move the 3x squared. We're gonna keep it on the right. I'm just rearranging here. Actually, let me back this up. I want to write this a little different here. Also, I made a little error here. I forgot to bring down the x with the 8. So let me clean that up. So let's subtract 3 from both sides. So 0 equals... Now I do want to rearrange this and put it in standard form. Remember, x squared, then x, then the constant should be the order. So that would be 3x squared minus 8x minus 3. Now, how would I solve that from here? You can either try to factor. I wouldn't be a fan of that because of that 3 in front of the x squared. What I would do, remember, you can solve any quadratic with the quadratic formula. So that's what I'm going to do. Let me, as a reminder, I'll write it to the left here. I have it memorized, but some of you guys don't. So feel free to write that down on your paper. So A is 3, B is negative 8, and C is negative 3. So I'm going to plug into the formula to solve for x. Remember, I can get 2 answers here because my highest exponent is 2. So negative b, but the b is a negative 8, so that's double negatives would be positive 8. Plus minus. Then b squared, so that would be negative 8 squared, which is 64. Please remember, when you square a number, it's always going to be a positive. Please do not put negative 64 there. When you do b squared, it's always a positive. And then minus 4 times A times C divided by 2 times A. All right, so let's continue to simplify this and get our two answers. So negative 4 times 3 is, let me show you what I'm doing. Right here, I'm multiplying these three numbers together. Negative 4 times 3 is negative 12. Negative 12 times negative 3 is 36. And then in the denominator, 2 times 3 will get 6. The radical, we can add the 64 plus 36 to get 100. And next, we want to work on that radical now that it's down to one number. Square root of 100 is 10. And now we can split up and get our two answers. So 8 plus 10 over 6. That'll be 18 over 6 is 3. And then 8 minus 10 over 6, that'll be negative 2 over 6 is negative 1/3. So there's your two answers, 3 and negative 1/3. So as you can see, these properties that we just learned today in A and C, they did turn out to be pretty easy, but sometimes we're going to hit up really difficult ones, such as letter B. So try your best and you'll be good. So let's scroll down. So now scroll to assignment 5.5. And now you guys should be prepared to do numbers 1 and 2. I'll give you a hint on how to start these. Like number 1, you would say, okay, 81 has to change into 3 to the power of 4. Number 2, 32 can drop down to a 2. 2 to the power of 5, which we discussed earlier. Here, we have a 2 and an 8. So the 8 can be changed to a power, 2 to the power of 3, like we discussed earlier. Number 4, 27 can turn into a power with 3. 3 to the power of 3. Number 5 we can't do because 33 cannot turn into a 2. Can't do 6 yet. I'll teach you in part 2 how to do those. There were a couple others. 7 you can do because 125 can turn into a power with a base of 5. It would be 5 cubed. Number 8 you can also do. 16 can turn into a power with 4. 4 to the second power. And that's it. So I prepared you guys to do 4 problems here. They're definitely a lot easier than you saw in the lesson. Like you won't see one here in today's assignment as difficult as B. So just they're going to be more like A and C. So try your best and be good.